Hello everyone, I'm Stefan Battifo. I'm a developer advocate for Milvus. We are an open source vector database. And today in this tutorial, I'll show you how you can build a GraphRAG system using Llama 3, Milvus, and Neo4j. GraphRAG has been making a lot of noise lately, especially since Microsoft published an article about it and explaining, how it can, in some cases, improve your RAG systems. In this tutorial, you'll be able to have a GraphRAG running that will actually route different questions to different parts of your stack, and then generate Cypher as well directly to use Neo4j, and finally generate your answers, check for hallucination, check if your generation is grounded, and then give you an answer. So yes, let's get started and let's go into this tutorial. I'm going to use the code that is available directly in our bootcamp. So if you want to have a look at it, you can go to our GitHub, milvus-io, and then the bootcamp section. And there we have a lot of different examples actually on how to use Milvus and how to build different AI systems. So we can build some RAG systems. We can also build some image search or audio search or different things like that. I'm going to run my code locally, so I have it running directly in a Jupyter notebook. And what we're going to do is that we're going to build a GraphRAG agent using Llama 3, using GPT-4o, and then on top of that, we'll have Neo4j for the graph database, and then we'll have Milvus for the vector store. So yes, I've been talking about GraphRAG a bit, but this is the architecture of our system. So, you have the usual part of the RAG system. So you have your data, and then you're going to extract the content, and then you're going to do the usual chunking. But then instead of only creating embeddings and then pushing them into Milvus, what we're going to do on top of that is that we're also going to generate the knowledge graph. And then once that is generated, then we're going to put it in Neo4j. Then when our user is coming, we will have two different search. So we will have, the query that is going through the embedding model. Then you run the semantic search. But then we also have text-to-cipher search, which then will search directly into Neo4j. Then we return the similar data. We give that back to the context of the LLM, and then we will have our response. So it's a bit different. It had a bit more complexity, but in some cases it can be useful. So yes, let's go and build it. So I'm going to use Ollama to run my Llama 3 model. And then I have my Neo4j, API keys and everything. Everything is running in the background. So I am just going to load those. And then just remove the debug mode of LangChain so it doesn't talk too much. I'm going to use Llama 3.1 directly. And then for the data, I'm getting data directly from Archive. So Archive is a website where you have a lot of different research papers. And then I'm only going to get 20 papers. And then I want papers that are either about agents or about large language model or about prompt engineering. And then we're going to do the search. And then, now we have those, we have the search. And then we're actually going to create the Milvus vector store. So we're going to use the LangChain integration directly. So, from LangChain Milvus, you import Milvus. And then I'm going to iterate over my results, over my search results. And then, I'm going to add some metadata as well. So I'm going to add the title, the summary, and the URL. Then we split our text. So, we're going to create chunks of 500 with an overlap of 50, meaning that the 50 characters before my chunk will also be added, and the 50 characters after my chunk will also be added, which helps, like in setting a bit of the context so that your LLM understands things better. And then we're splitting the documents directly. So let's go. Okay, that is done. So we have 20 papers and we have 20 chunks. So that's what we store directly then in our Milvus database. So I created here directly. I'm giving it like a name for the collection. I'm using Hugging Face embeddings. And then I'm just giving the URL so that LangChain then knows that it has to use Milvus Lite, which is running directly on my laptop. I'm just going to call Ollama with a, Llama 3 that I've defined before. And here, this is where I define the GraphRAG setup. So I have my Neo4j graph, which is also like something that you have directly into LangChain. And then I'm going to use GPT-4o here to actually generate the graph because it gives better results for the graph generation than Llama 3. And yes, then I'm just saying, hey, the nodes that I want are paper, author, and topic. And then for the properties of the nodes, I want to have title, summary, and URL. And then for the relationships, I want to have authored, discusses, and related to. Then here, we're actually going to convert everything to a graph document. So this is when then, we have our splits of documents, but this is where then we're going to transform everything into something that is graph-based. And then here, the graph here is our Neo4j graph. So we're just adding all the documents to this graph. And then hopefully we can build some relationships and we can have some nodes and then we can see things that relate to each other. So let's go for it. Okay. So now everything is done. We've actually transformed all our documents and added it to the graph that we have in Neo4j. So then you can see, I have 20 graphs, and then you can see here the nodes from the different graph documents. So this one, the idea is prompt design and engineering, and that's like some kind of topic. And then we have the same for large language models, and different things. But then we can see we have other topics now that have been created, thanks to, the relationship that we have in Neo4j. And then we can see also like, different properties. So the prompt design and engineering paper, for example, which is some kind of paper. Then we have the summary, that belongs to it. But then we can see also that some nodes, have like a type that is discusses. So it's like, okay, we're talking about this one in this paper and that thing. And then if you want to have a more look, then you can see, the first document. So the idea is prompt design and engineering. And then you can see like, you have like a lot of relations, for like different nodes. So like a relationship here, with this source, which is like prompt design and engineering paper for the type paper. And then you have the same, for the topic, and then obviously those two are related because the paper and topic are the same basically. So yes, so this is what we have, over our documents. And then you can see we also have like things that relate to it, and everything. So yeah, our graph now has been built. And now we're going to add a part of the agentic RAG system, sorry. So this one, we're just going to add, multiple steps to make sure that actually we're giving the correct answers. Also, like which route to pick and everything. So I'm just going to define all of those and we're going to do it together. And then hopefully you'll have a better understanding of how then you can build a GraphRAG system. So here, what we have, it's a retrieval grader. So we're just grading what we're retrieving because we want to make sure that actually what we're retrieving is good. And if it's not good, then we want to make sure that we actually say it. So this is what we have. You are a grader assessing relevance of a retrieve documents to a user question. And then you're just basically checking if we contain keywords that are related to the user question or not. If yes, then we give a binary score that is yes, and otherwise we say no. And that's it. We only want to have yes or no as an answer. So I'm going to ask my question here. So do we have articles that talk about prompt engineering? Then here, I'm just going to retrieve some documents, and that's what we have. And then I'm just asking, like I'm just printing to see if we have a result. So here, we're going to go over, all the documents, and then we're going to check if we're actually saying an answer that is correct or not. So yes, we can see that, like the RAG agent was like, okay, actually we're answering the question. I could actually show them the answer, but for this one, you have to trust me. And then we have something here that is similar. Here is just to generate actually the answer, because otherwise the LLM might generate answers that are too long or too short. So we're just telling the LLM to use 3 sentences maximum, and to keep the answer concise. And then we're just formatting, the documents to make sure it's pretty. And now you can have a look. So if I ask the same question, do we have articles that talk about prompt engineering? Then we should have a generation. So yes, we have something here, which is the study found that the prompt engineering integration had a positive impact. And, basically that's what's happening. Like here, the LLM generated this text based on our prompt. And then here is where we're actually going to use Cypher. So this is where we generate the Cypher code. So then we can actually make queries to Neo4j. So again, I have my prompt, that is here. And then it's like you're an expert at generating Cypher queries for Neo4j. Use the following schema, and make sure that we can use it and focus on searching paper titles as they contain a lot of information. That is what I've defined. And then I have another one that is a question answering task, which is then using Cypher query to answer the question. So then if you don't know, just say you don't know. And again, use 3 sentences maximum. So then I'm, generating the GraphRAG chain. So we are generating the Cypher code with the LLM, also the question answering code as well. So we're using the LLM for that. And then, making sure Cypher is actually running. And yes, so I'm asking my question, what paper talks about multi-agent? So, we can see we entering the Cypher chain, and then, we're matching, paper where the title contains multi-agent. Then we return the title and the URL. So we can see we have this one, so this one is the title multi-agent assistant code generation, and then we have different ones like that. But then we can have vector and graph search. So this one, is actually check in the vector store and the graph database as well. So we're going to use it, and then I'm asking you the same question, what paper talks about multi-agent, and then we can check, this one is actually both. So we can see we have a summary here of a paper, and this one is leveraging multiple large language models, agents, and then so I guess this one is talking about multi-agent. So we're happy. And the title was Adaptive in Conversation Tier Building for Large Language Models. And then you can see the URL and everything. And then you have that for different documents. I won't show you everyone because it's quite a long one. But then, yes, if we want to use only the vector context, then we can also have a look. And then we also have a look at only using the graph context. So yes, for the vector search, we also see something which is actually the same paper. So this one we're happy. And for the graph, we have a different one. We return a different one, but it's also something about multi-agents. So then it's still fine. And then here, yes, here we have the composite chain. So this one is really running the whole chain. So checking that everything is fine. Plus GraphRAG plus vector search. And then here we can see the answer. It's like you're talking about adaptive in conversation tier building for language model agents, sorry. And this one talks about multi-agents. And then, the LLM is actually talking and, generating an answer to give you a bit more information without writing too much. Now, I have another one. This one is a hallucination grader. So this one is, making sure that actually the answer you're giving is grounded in or is supported by a set of facts. And again, we give a binary score of yes or no. So we're going to ask the LLM, we're going to retrieve our documents, and then we ask the LLM, hey, are you happy? And the question was the same. So yes, we have, something that talks about something. So then you're pretty happy about it. And then we can, also grade our answer. So it's actually, are we happy with our answer? And then it's the answer that I've had before. And my question was would which paper talks about multi-agents. So this one is clearly, talking about agents. And so then if I ask, hey, did I answer actually correctly? Then the answer is yes. And now I have something that is a bit more complicated. It's a router. So I'm defining a router that will then, tell where to go based on the question. So either you're going to go to the vector store, if it's question about LLM agents, prompt engineering or everything. Maybe you're going to go to the GraphRAG if, you have some questions that are involving relationships, between entities, such as like the authors or papers or something. And then as a fallback, I have a web search as well. If you ask questions about like current information or like other questions as well. And then we are basically returning the data source. So either vector store, GraphRAG, or web search. And I'm asking a question just as a test, LLM agent memory. And for this one, we are saying, okay, this one is vector store because, it's what is defined here. This is about LLM agents. For the search, I'm using Tabuli, which is, a search engine specialized for LLMs. So I'm just defining it here. And here, this is where the tricky part is, basically. So this is where we define LangGraph. So for LangGraph, we have to define, graph state, which is like the state of our graph. And then we're going to give different attributes. So the question, which is the question of the user. The generation is the LLM generation. And then web search, whether to add search or not. The list of documents. And then also the results from the graph search. Then we have different nodes where, we have like nodes which are basically state. So this one we have, you're going to retrieve some documents from the vector store. This one is generating an answer using RAG on the retrieved documents and the graph context that you also were given. This one is grading documents, is going to use, what we have before. So it's making sure if it's relevant or not. This one is a web search. So this one is based on the question. So, it's going to use Tabuli, as I said before. And then this one is going to be our router. So, if the data source is GraphRAG, then we're going to do the graph search. If we don't have any results, we're going to fall back to the vector store. And then same here for the vector store, and then same here for web search. Then we're checking if we're happy, and then if we're happy, we're going to generate an answer. Otherwise, we're going to add web search to it. So, it's like if we decide to do a web search, then we're going to do one. And then otherwise, we're happy with our answers, so we can generate an answer. Then I'm also defining one, to perform GraphRAG search using Neo4j. So this is what you have here. You're going to use your GraphRAG chain with a query, which is the question. Then you get the result, and then you give that back to the result. Then, because it's not over, it's quite a long one. Then you have conditional edges. So those ones is like, grading the generation with regards to the documents and the question. So it's like, okay, was it actually grounded? And does it actually answer the question? So, you have everything here. So, if we're happy, then if we had returned yes, then it means we're happy. So then the generation is grounded. And then we're going to check, grade the generation against the question. Are we actually answering the question? If yes, then we return useful. Otherwise, we return not useful. And then otherwise, we return not supported. And then basically here, we define all the nodes. So web search, which is going to call the web search function. Retrieve, which is going to call the retrieve function. Grade documents is the same, generate, and GraphRAG. So let's go. So now this one is defined. So we're happy. And now we can build it actually, so we have to add, the entry point. So here the entry point is going to be a router. So it's either you do the web search or retrieve or GraphRAG. And then you're going to add some edges, to like, okay, actually, are we retrieving? Okay, if we retrieve, then the next one is grading. GraphRAG is generating and everything. So I start it, and now we can ask questions and see what kind of answers we will have. So my question is, what are the types of prompt engineering? And it's going to go through the whole flow that I've defined before. So, okay. So first, the data source, by LLM decided that it would be vector store. So we're routing the questions to the vector store. Then we're retrieving. We check the documents to see if they're relevant to the question. We see that actually the documents are not relevant, or not relevant. Okay. So then we've answered that all documents are not relevant to the question. So then we're going to do a web search. Then we generate, actually, based on the web search. And then we're checking for hallucination. And then we check, is it grounded in documents or not? And then because now we're happy, now we can actually generate something. So based on my question, what are the types of prompt engineering? Apparently, we didn't have it in the vector store. So then we did a web search. And then the result is, okay, there are different types of prompt engineering, including zero-thread prompting, listimos prompting, and everything. So we got an answer, which seems, like a good one. And then we didn't have it in our vector store. So then we did, a web search for it. We can also check, maybe, hopefully, hitting the GraphRAG system. So I'm going to ask a question, which is, which paper talks about code generation? And then, we're going to route the question. So first, we're going to go to the GraphRAG, because I'm kind of asking, about a title here or something, So then we're going to go to a GraphRAG system and then try to see if we find an answer here. So we're generating some Cypher, Cypher code. So then we can then use Neo4j. And then, okay, we're happy. It seems like we finished. We generate our text. We check for hallucination. We actually see that our answer is grounded. And so then we can answer it. So then we generate the final one. And then the answer is like the paper that talk about code generation are multi-agent assistant code generation, pair coder, code powery, and then, you have different answers like that. And this is when, it can be really good to use a GraphRAG system, especially when you have entities, when you have a lot of data that are related to entities. I hope you liked this tutorial. If you liked it, I'm Stefan Batifo. You can find me on socials. Also, would really appreciate it if you were to leave a star on Milvus, on GitHub, as it really helps us. Thank you very much and have a good day.